Hello Avalanche, and welcome to tutorial 2 of the Avalanche Pathway. In this video, we'll be creating your first Avalanche account on Xchain using the Avalanche JavaScript API and DataHub. We will also be funding it with Fuji testnet tokens. So let's go ahead and navigate to the Avalanche tutorial 2 in your DataHub dashboard and click Start to begin. Unlike other popular blockchains, Avalanche comes with a set of different chains, each for its own purpose. Xchain for asset transfers, P-chain for network validators and staking, and C-chain for smart contract execution. The Xchain acts as a decentralized platform for creating and trading digital smart assets, a representation of a real-world resource, for example, equity or bonds, with a set of rules that govern its behavior, like can't be traded until tomorrow or can only be sent to US citizens. One asset traded on the Xchain is AVAX. When you issue a transaction to a blockchain on Avalanche, you pay a fee denominated in AVAX. The P-chain is the metadata blockchain on Avalanche and coordinates validators, keeps track of active subnets, and enables the creation of new subnets. The P-chain implements the Snowman consensus protocol. The C-chain allows for the creation of smart contracts using the C-chain's API and is an instance of the Ethereum virtual machine powered by Avalanche. Please make sure you've completed tutorial 1 before continuing this one. We will be building on top of the Node.js application created in the previous tutorial. Now we can move forward with creating an account. We're finally ready to jump in and create our first Avalanche account. There are currently a few ways to create a new account on Avalanche Network. Programmatically with Avalanche JavaScript API, which we'll do in this tutorial, or in browser by using the Avalanche wallet. We will be creating out account programmatically using the JavaScript client package. However, you might find it useful to explore other options. Let's start by creating a new file, create_account.js, and we're going to do that inside of our project we've been working on. Here it is. So to create a new file, we click that button, put in the name, account_create.js, and then we can go back here and grab the code that we will be putting in there. And save. If this looks familiar, it's because we used the same code in the first tutorial. We will be adding our code within the body of the main function. So let's go back to DataHub. Before we can issue transactions on the network, we will need to create our private key. A private key is used to sign transactions on any Avalanche chain, X, P, or C. And for educational purposes, we'll use a single private key during the pathway. To manage the keys, we first configure the keychain, a component for managing private or public key pairs and addresses. We will be storing the secret key in ./credentials/keypair.json. We will be storing the secret in file ./credentials/keypair.json, so make sure to create the directory credentials first. On Mac Linux, you can do so with the make directory command, followed by credentials. So let's do that. mk dir make directory credentials, and we can see it got added right there. Onto the code. We're going to replace number 1 under the main with this bit of snippet. And then save. We have instantiated the Xchain client and the keychain. Next, let's add the part to create a new key or read an existing key from the JSON file. So under 2, we'll put this section. And save. The key functionality above is keychain.makeKey generates a new private key. You can have as many private keys as you like for different purposes, like staking or token transfers. Keychain.importKey loads an existing private key. Could be loaded from an environment variable or a file in our case. So far, we have generated a private key and can print out its X-chain address. We want to show the address so we can use Avalanche Faucet to request funds for testing. Avalanche Faucet is a service run by Avalanche to fund accounts on Fuji testnet for development purposes. Funds are not real and could be requested at any time, given that you can pass the CAPTCHA. Finally, we add the last chunk of code to perform balance checking of our X-chain address. We're replacing 3 check address balance part of the main function with this bit of code right here. And save. An address on Avalanche network might have balances for different assets, not just AVAX. For that particular reason, it's easier to use chain.getAllBalances method instead of chain.getBalances address asset ID, as one must know the real asset ID and not its symbol before a call like that could be made. We'll cover that part later in the pathway track. Great, we've covered all parts of the process from keychain configuration to balance checking. Let's go ahead and fire it up by running node create_account.js in our terminal. All right, there's our X-chain address. We're going to need that. So you should see a similar output to this and like what I got. Looks like everything worked. However, our X-chain address does not have a balance, which means we will not be able to send funds to another address until we get some test tokens. So let's head on over to the Avalanche Faucet page, enter the address from the output above, must be our own address, like this one right here, and then right-click, request one AVAX. You should see the successful confirmation page, meaning your address is now funded with one AVAX. So we can go to the testnet faucet, put in our address, prove we're not a robot, and request. And there we go. So now if we go to the Explorer, we can put in our address over here, hit enter, and we can see our balance. Now we can rerun the node create_account.js command and should be getting the balance output this time. Should look similar to this. So we can go ahead and run that code. And there it is. There's our one AVAX right there. Success! You've got money in the bank. Avalanche native currency uses 9-digit denomination, so a value like this is really a 1 in human readable form. You can also check your newly created address using the Avalanche Explorer like I showed you how to do. Make sure to go back to DataHub and verify you have completed the step properly. You now have an account or an address on the Avalanche Fuji testnet, and your private keys are stored in the credentials/keypair.json file. Your account is also loaded with test tokens that you can use for testing purposes. You also have learned how to check account balances using the DataHub node. In the next tutorial, we will be looking at different queries we can run against our network node to get the following information: validator set, address balances, current block height, and minimum fees for transaction. As always, if you had any difficulty following this tutorial or simply want to discuss Avalanche and DataHub tech, you can join our Discord in the link down below. I look forward to seeing you there, and until next time, happy coding.